right, for this problem, we're going to take a look at the antiderivative of 1 over x minus 1 cubed times x plus 2. As you can probably guess, this will be a partial fractions problem. And so let me do the real work down here. 1 over x minus 1 cubed times x plus 2. This is a quartic polynomial, and so we'll have 4 unknown constants. Here I have a linear term cubed, and so that will spawn 3 terms, a over x minus 1 plus b over x minus 1 squared, and then c over x minus 1 to the third. And then last will be d over x plus 2. Clearing out the denominator, we get 1 is equal to a times x minus 1 squared times x plus 2 plus b times x minus 1 times x plus 2 plus c times x plus 2 plus d times x minus 1 to the third. Okay, to do this, I will plug in numbers to get started. So if we plug in x is equal to 1, then on the left side we have 1. On the right side, that goes away, and that goes away. This term, if I plug in 1, I get 3 times c, and so that means c must be equal to 1/3. The other thing that I can plug in that's easy is -2. If I plug in -2, that goes away, and that goes away. Plug in -2 here, I would get -3 to the third, -27d. And therefore d is equal to -1 over 27. Okay, from this point forward, I have 2 options. I could multiply out and match coefficients, and that would work. What I'll choose to do instead is to plug in 2 more numbers and get a system of 2 equations and 2 unknowns for the remaining variables a and b. So I'll start off by plugging in 0. If I plug in 0, I still have 1 on the left. If I plug in 0, I get 1 times 2, so 2a. Then I get -1 times 2 if I plug in 0, so minus 2b. If I plug in 0, I get plus 2c, so plus 2/3, because I know c is a third. Plug in 0 here, I get -1, so -1 times -1 over 27 makes plus 1 over 27. And so solving, we get 2a minus 2b is equal to, if I bring these over and simplify, I get that's equal to 8 over 27. And therefore a minus b is equal to 4 over 27. And so that's equation number 1. Equation number 2, I will take again this line here and I'll plug in something else. So let me plug in 2. If I plug in 2, I get 1 is equal to, plugging in 2, I get 1 times 4, so 4a. Plug in 2, I get 1 times 4, 4b. Plug in 2, I get 4 times c. I know c is a third, so plus 4/3. Then plug in 2, I get 1 times d, so -1 over 27. So bringing the constants over, I get that 4a plus 4b is equal to -8 over 27. And then dividing by 4, we get a plus b is equal to -2 over 27. So here I have my 2 equations and 2 unknowns for my a and the b. To solve these, I can do a 2-by-2 system, but what's a whole lot easier is to add them up. If I add them together, I get that 2 over 27 is equal to 2 times a, so that a is equal to 1 over 27. And then I can plug that back up here. So let me just take the bottom equation. -2 over 27 is equal to 1 over 27 plus b. And therefore b would be equal to -3 over 27 or -1/9. Okay, so let me store that information up here, that a was equal to 1 over 27 and b was equal to -1/9. And so I can now set up my partial fraction decomposition. This is equal to the integral of a is 1 over 27 over x minus 1. b is -1/9 over x minus 1 squared. c is a third over x minus 1 to the third. d is -1 over 27 over x plus 2 dx. And so I find the antiderivative to be 1 over 27 times the natural log of absolute value of x minus 1, then plus 1/9 times 1 over x minus 1. Then I have minus a sixth, 1/3 times a half of 1 over x minus 1 squared, then minus 1 over 27 times the natural log of x plus 2 absolute value plus c. And so that's the answer. We expand in the partial fraction decomposition and then take each one of these and integrate.